In this video, we will learn how to decompose price effect into substitution effect and income effect using Hickian method. The question is, suppose consumer's utility function is being given as u is equal to 3x raised power 1 upon 3 times y raised power 2 upon 3. X and y are the two goods that the consumer consumes. Price of good X is $10 and price of Y is $10. Initially, income of the consumer is $120. Suppose price of X decreases to $5. We have to find out the substitution effect, income effect, and price effect. Okay. So first, we should know what is meant by price effect. Okay. So price effect means how much quantity demanded of a good increases or decreases due to change in the price of that very good. Okay, simple thing. Now this price effect has two components. One is the substitution effect, another what we call the income effect. Substitution effect involves the substitution of one good for another due to change in the relative price of the two goods. That is to say, how much quantity demanded of good X in this case will be demanded due to the substitution effect. And let me explain it. Suppose, and what we have here, price of X, if it decreases, so good X becomes relatively cheaper compared to other goods, that is Y here. When it becomes cheaper, it will be consumed more. Okay. So since price of good X has decreased, it became cheaper and quantity demanded of good X will increase. This is what we call the substitution effect. By income effect, what we mean? Income effect results from an increase or decrease in the consumer's real income or purchasing power as a result of the price change. That is to say, how much quantity demanded of good X will be due to income effect depends upon how much consumer's real income increases or decreases. In this case, let me explain. So since price of good X has decreased, consumer's real income will increase. When real income increases, that means quantity demanded of good X will increase. And how do I explain? Simple thing. Let us suppose initially, let me give a hypothetical example. Let us say price of good X was initially, let us say $10. Income of the consumer was, let us say, $50. So quantity demanded of good X, as we know, it will be equal to, if consumer spends all income on the purchase of good X, so quantity demanded of good X will be equal to income upon price of X. So we have income 50, price is 10. That means consumer will demand 5 units of good X. Now let us suppose price of good X has decreased to $5. Okay. Now income, let us say it is same, which is 50. Now what will be the quantity demanded of good X in this case? It will be equal to total income upon the price of good X, which is $5. Here you can see consumer is demanding 10 units of good X. With the same income of $50, this time consumer is able to demand 10 units of good X. We call this the income effect. That is, with the decrease in the price, consumer's real income has increased. So with the same income, now he is able to demand or consume more units of good X. That is what we call this income effect. Now price effect is equal to the substitution effect plus income effect. Okay, we need to find out in this question how to solve that very thing. Now let me rub this out. I hope you are done with this a little bit summary on the substitution effect, income effect, and price effect. Now to solve using the Hickian method, what will we do? First, we will see what will consumer initially demand when the price is $10 for good X and $10 for good Y. How much he will demand. So let me draw a simple budget constraint here. Okay, So let me draw the budget constraint. Let us say this is initial budget constraint. Now for to find out the optimal bundle, as we know what we want to do, we want to maximize the utility of the consumer, which is 3x raised power 1 upon 3 times y raised power 2 upon 3, subject to the initial budget constraint. What are the initial budget constraints? That will be equal to price of good X times units of good X plus price of good Y times units of good Y should be equal to the income of the consumer. That is, price is initially $10, so we have 10x. Price of good Y is initially $10, so we have 10y should be equal to income of the consumer. Dividing both sides by 10, we will get x plus y is equal to 12. So subject to the initial budget constraint of x plus y is equal to 12. So first we need to find out the initial bundle of the consumer. Now solving this, we know for optimization what we do, we equate the marginal or rate of substitution should be equal to the ratio of the prices of the two goods. This is the initial condition, as we know. MRS, as you know, it is simply marginal utility of good X upon marginal utility of good Y. It should be equal to price ratio, price of X upon price of Y. MUX, as you know, it is simply the change in the utility due to the consumption of good X. The change in the consumption of good X. Similarly, MUY means the change in the utility due to the change in the consumption of good Y should be equal to price of X upon price of Y. Solving further, taking partial of this function with respect to X first. So 1 upon 3 becomes coefficient. So we have 1 upon 3 times 3 x raised power 1 upon 3 minus 1. Using power function rule, it becomes minus 2 upon 3. Y raised power 2 upon 3 will remain same because we are taking partials with respect to X. Symmetrically, we take the derivative with respect to Y. So this time we will get the exponent of Y is 2 upon 3. It becomes coefficient. Then we have 3. X raised power 1 upon 3 will remain same because we are taking partials with respect to Y. The exponent of Y will be subtracted by 1. So we will get 2 upon 3 minus 1, which comes out to be minus 1 upon 3. It should be equal to price ratio. Initial price is price of good X is 10, price of good Y is also 10. So it is 10 upon 10, 10 or 10. So it is equal to 1. When we further solve this, 3 and 3 gets cancelled. If I transpose this X to numerator and this Y to the denominator, so what will happen? We will get 1 upon 3. Solving this, it becomes 3 upon 2. When I transpose this X here and this Y there, it will become Y upon X. You can check it out. Simple math. I will not go into further details. It will get lengthy then. Okay. Should be equal to 1. So 3 and 3 gets cancelled, or we get Y upon 2X is equal to 1, which implies Y will be equal to 2X. Okay. So that means finding the optimal condition, what will we get? So we require MRS, that is the slope of the indifference curve, should be equal to the input price ratio, the prices of good X and Y, the ratio of the prices, price of X upon price of Y. When we solve this, we got this result, that is Y is equal to 2X. Okay, now let me rub this out. So initially consumer's equilibrium will be, if this is the initial what we call the initial budget line. So let us suppose, let me draw the initial indifference curve like this. So let us say this is the initial indifference curve. So consumer is demanding, and let us find out here, since we got Y is equal to 2X, plug it into the budget constraint. So we will get X plus, in place of Y we have 2X again, should be equal to 12, which is 3X is equal to 12, or X is equal to 4. So X is equal to 4. Now what is Y? Y will be equal to 2 into 4, which is equal to 8. So 2 times the value of 4, which comes out to be 8 here. So consumer is demanding 8 units of good X and 4 units of good Y initially. Okay. So we first find out this initial bundle here. Let us say the tangency occurs at point, let us say P. So this or let us say simply tangent C is at point A. Now what happens when price of good X decreases? Okay, what will happen when the price of good decreases? So again we want to maximize the given utility function u is equal to 3 x raised power 1 upon 3 times y raised power 2 upon 3. Now what will be our new budget constraint this time? That is price of good X, let us denote it by px prime, that is new price times units of good X plus py times y should be equal to the income of the consumer. So this time price is 5, so we have 5x plus 10y is equal to 120. Dividing both sides by 5, we will get x plus 2y is equal to 5 2s are 10, the katba 5 4s are 20. Okay, again using, so what has happened when the price of good X has decreased? The budget line will pivot towards right, that is it will pivot like this. Let me use this color. So it will pivot like this. Consumer will demand more units of good X. Okay, again using the condition, that is MRS should be equal to ratio of the prices, price of X upon price of Y, price of X prime, let us suppose here. Solving again, we have found initially MRS was equal to Y upon 2X. You can check it out, Y upon 2X, which I solved here. Now what is the price ratio? We have 5 upon 10 this time, which is equal to 1 upon 2. Okay, which is equal to 1 upon 2. Using the condition here, we will get Y is equal to 2x upon 2 this time, which implies Y is equal to X this time. Now we plug the value of Y is equal to X into our budget constraint here. Okay, so what will we get? X plus 2, the value of Y is X here, should be equal to 24, or 3x is equal to 3x is equal to 24. Dividing both sides by what we call 3, we will get the value of X is equal to 8 this time. Okay, so consumer will consume 8 units of good X this time, and the value of Y will be equal to so Y will be equal to, plug X is equal to 8 in this equation, Y will be also equal to, so sorry, if X is equal to 8, Y will be also equal to 8 this time. So let us say it is, we have new indefinite curve this time, optimal condition requires. So let me draw it here. Okay, so with the change in the price of good X when it decreases, consumer is consuming 8 units of good X. Okay, I hope I am making myself clear. Now what happens next? Let us suppose this is point B. Now to find out, in this case, to find out or to calculate the substitution effect, what we do? We need to hold the consumer's real income constant in order to keep him on the original indifference curve. So this red line, rather red curve, is our original indifference curve. So we hold the consumer's real income constant, okay, so that his utility remains constant, initial utility, that is on this red indifference curve. That means we need to shift this line parallel, rather we will draw a new budget constraint that is parallel to this black budget constraint in such a way that it is tangent to this red indifference curve. Okay, so how do I draw that very let me use another color. So let me draw it like this. So let us suppose it is parallel. It is not parallel here, but let us suppose it is tangent to the original indifference curve at this point, and let us say it is point C. Okay, we need to find out this point C, what will be the quantity demanded on that very point. So for that, what will we do? Again, we want to maximize utility, that is u is equal to 3x raised power 1 upon 3 y raised power 2 upon 3. Now what will be the new budget constraint? That will be equal to the change in the price of good x, that is 5x this time. The value of x is 5 here, the price of good x 5x plus 10y should be equal to 120. Solving further, which we got here, x plus 2y is equal to 24, or when we solve for MRS is equal to the input price ratio, that is price of x upon price of good y. We got y is equal to x. Okay, this time what we need to do? We need to hold the utility level constant, which is original utility, and solve for, that is, we equate. So let us first find out the utility what the consumer will get. So what is the initial utility that he is deriving on this red indifference curve? That will be equal to u is equal to, so initially x is 4, y is 8, plug the values here. So we have 3, x is 4, that means 2 square in place of 4. Let me write 2 square raised power 1 upon 3. In place of y we have 8, I can write 2 cube whole raised power 2 upon 3. So u will be equal to 3 times 2 raised power 2 upon 3 times 2 raised power 3 gets cancelled, so we get 2 square, or initially utility will be equal to, so we have 2 upon 3 plus 2, so this is 2 upon 3 plus 2, so this becomes 2 plus 6 divided by 3, so which becomes 8 upon 3. So we have 3 times 8 raised power we have 3 times, base are same, we are the exponents, we get 2 raised power 8 upon 3. This is the initial utility he is deriving. So to find out the quantity demanded due to the substitution effect, what we are doing here, we are holding the utility constant, okay, and we solve for this budget line. So since we again got y is equal to x, now what will we do? This is the utility level that the consumer is deriving. So for that, what we are trying to do, we equate this utility function with the utility that we derived and plug the value of y is equal to x, okay, to find out this point where we hold the consumer's utility level constant and our budget constraint is tangent to this red indifference curve. Simply we have to maximize this utility function subject to the new budget constraint. Then we got y is equal to x. Now what is the initial utility? This very thing is the initial utility. We equate it in this equation, then we plug the value of y is equal to x to find out the value of x. So in place of u I write this stuff, or let me write it like this: 3 x raised power 1 upon 3 times y raised power 2 upon 3 should be equal to utility that the consumer is getting, that is equal to 3 times 2 raised power 8 upon 3. Here 3 and 3 gets cancelled, but we know that y is equal to x. Plug the value of y is equal to x here, so we get x raised power 1 upon 3. In place of y we have again x, so we have x raised power 2 upon 3 should be equal to 2 raised power 8 upon 3. bases are same, we can add up the exponents. So 1 upon 3 plus 2 upon 3 becomes 1. So we will get x is equal to 2 raised power 8 upon 3. Okay. Now what is the value of this thing? Now I have to calculate it. Okay, let me first solve this. So we have x in place of, so we have 2 raised power 8 upon 3. So it comes out to be 6.35. Okay, so this point is 6.35. Okay, now see here, the movement from A to C denotes the substitution effect, and the movement from C to B denotes the income effect. Okay, why this is substitution effect? Because consumer's utility is same here. It is we hold this constant, and from the movement from C to B denotes in fact our income effect. The rest of the effect is the income effect. We can check it out also. So what is price effect? So price effect, as you know, price effect should be equal to the substitution effect plus income effect. Now when the price of good X has decreased, quantity demanded of good has increased to $8. Okay, so initially price so initial quantity was 4. When price decreased, quantity demanded is equal to 8. This is our substitution effect, sorry, the total price effect. And what is the substitution effect? Here we can calculate the movement from A to C denotes the substitution effect, that is 6.35 minus 4. So we have 6.35 minus 4 minus 4. So we will get here 2.35. So 2.35 units of quantity demanded is due to the substitution effect, and the movement from C to B is income effect, that is 8 minus 6.35. 8 minus 6.35. So 10 5 5 9 3 7 8 1.65. So income effect is 1.65. So it shows us that when the price of good X has decreased, quantity demanded of good has increased. Okay, so initially quantity demanded was 4, it increased to 8. So this gap is equal to 4. I have written it here 8, sorry, again good. So we have 4 here. Now the price effect, the change in the quantity demanded, which is equal to 4, is in fact equal to the substitution effect. That means 2.35 units of the quantity demanded which increased is due to the substitution effect, and the rest is due to the income effect, that is 1.65. When you add these up, it should also come out to be equal to 4. Okay, I hope I make myself clear in this video. Okay, so what we have done here, if I can recapitulate it. So initially consumer was on this budget constraint and he was consuming at this point. Okay, this was the initial equilibrium point. When the price of good X has decreased, quantity demanded of good X has increased. That means this budget line has pivoted towards right. Now at this new pivoted budget line, we find out the equilibrium at point B. That means quantity demanded has changed to 8 units. The movement from A to B is our price effect. Okay, since we want to find out the substitution effect, what we do in this case, we need to hold the consumer's real income constant in order to keep him on the original indifference curve. So we do it by the same fashion. What we do, we draw a new parallel line, new budget constraint which is below, parallel to this budget constraint in such a way it is tangent to the initial indifference curve. That means initial utility of the consumer is constant, and we find out the new optimal bundle. then we decompose it into price effect and substitution effect. I hope I make myself clear in this video and you find out this video helpful. Thank you.